Okay, here we want to take a look at a couple theorems. I'm not going to test you on restating these, but I will test you on your knowledge of being able to use them. The first one is the remainder theorem, and that says that if a polynomial function is divided by x minus c, its remainder is the same as f of c. Okay, so if I were dividing by this and doing either synthetic or log division, whatever I get as a remainder would be exactly the same thing as if I took the c and just plugged it into my function. That's pretty cool. Okay, the factor theorem says if I have a polynomial function, x minus c is a factor if and only if f of c is 0. So it's a factor if when you plug in the c you get a 0, and if and only if means it works backwards too, so that if f of c is 0, then x minus c is actually a factor. Alright, so let's put this together and say, well, how are we going to use it? What am I going to expect you to be able to do? Well, I'm going to expect you to be able to check to see if x minus c is a factor by just simply dividing, okay, and making sure the remainder is 0, or by checking if f of c is equal to 0, okay, that's using the factor theorem, or get the graphical connection and show that there's an x-intercept at c. And that would only work, of course, if I have real numbers, but a lot of what we're doing will be real numbers, so that's a really important one to remember. We can also evaluate a function at a given value by plugging it in, of course, what we've always done, or according to our theorems there, we could just find the remainder by dividing f of x by x minus c and seeing what we get. And we could do synthetic division, so it'd be pretty quick. Let's take a look at an example. If I have f of x equals x cubed plus 2x squared minus 8, and I want to find f of 3. I could plug in 3, and it wouldn't be too hard because 3 is not a big number, but I want to try using my theorems here and do synthetic division instead. So I would take this number that I'm evaluating at, and that goes in my divisor box there. And then I complete the rest of this first row by using the coefficients of what my function is. But you notice that we went from x squared to negative 8. We don't have an x term, so when I write my numbers out, it's 1, 2, 0, minus 8. So don't forget those placeholders for missing terms. Drop the 1 and multiply, and then add, multiply, and then add, multiply, and then add, and we get a 37. This last one is always our remainder, so this is telling me that f of 3 is equal to 37. Well, that'd be 3 times 3 times 3 is 27, plus 3 times 3 is 9, 18, and then minus 8. Yeah, that would be true. But synthetic division is actually maybe a little bit quicker or easier because the multiplication is involving smaller numbers for the most part. All right, last one. Use synthetic division to determine if negative 3 is a 0. Well, if I'm checking to see if negative 3 is a 0, then I'm checking to see if x plus 3 is a factor. So I'm going to go ahead and I will put that negative 3, that potential 0, right out here in my divisor box. And there's no missing terms this time, so I just copy my coefficients. We do the drop and multiply and add stuff until we get down here at the end, and we have 0 as a remainder. Since the remainder is 0, that tells me that yes, negative 3 is a 0. But remember, I want to be able to check things as many ways as I can, so if I go to my calculator and I input f of x here, right, and I look in the standard window, I should expect to see x-intercept is 0 at negative 3, and I do. I don't see a very nice graph here, but I can tell that it crossed at negative 3, so it's a good thing to confirm graphically.